All right, welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are basically going to look at the mat102 quiz 1 for last year. Okay, so this is the question. Okay, we are to show that this question is basically on coordinate geometry, straight lines. Okay, so we are to show that the point P of coordinate 3 and 3, Q of 8 and 17, and that of 11 and 5 for R are the vertices of a right angle triangle. Okay, so once you sense this kind of question, first you have to think of is right angle triangle. What is it? You know, when you mention right angle triangle, it means that it forms some angle which of 90 degrees inside, right? And once it forms that, then you can say that we are going to use the Pythagorean theorem, right? So we know that if you have this illustration, okay, if you have this illustration, you know that P, Q, and R, it's following a particular order, right? You don't have to miss the coordinates or the points. Okay, because P comes before Q and Q comes before R. Don't mix them up, right? So once you mix them, you're going to have different results. Okay, so we have our P here, we have our Q here, and we have our R here. Don't forget that it's a right angle triangle, so we're going to form this. Okay, so coordinate of P is 3, 3, and that of Q is 8 and 17. R is 11 and 5. Okay, so you know what we are going to do? We're going to apply the Pythagorean theorem. So we know that the longest side of the right angle triangle is the hypotenuse, right? And you know that the distance along PQ squared should be equal to the distance along this side and all squared plus the distance along this side, right? So we're going to have distance along PQ all squared should be equal to distance along QR all squared plus distance along PR all squared, right? So this is basically the Pythagorean theorem, right? So here we have to find the distance one after the other. Once we are done, then we sum these two. If indeed this two is equal to this, then we can confirm that these vertices are for a right angle triangle. Okay, so here we go. We're going to have PQ, distance PQ equals square root of x2 minus x1 all squared plus y2 minus y1 all squared, right? And we know the coordinates for P and Q. So let's put that down. 3, 3, and Q of 8 and 17, right? So this is x1, y1, x2, y2, right? So we're going to substitute this coordinates into this formula. So here, our distance PQ will be equal to square root of x2 is 8. So we have 8 minus x1, which is 3, all squared plus y2, which is 17, minus y1, of course, is 3 all squared. So distance for PQ is going to be 8 minus 3, which is 5, right? And 5 squared is 25 plus 17 minus 3 is 14. 14 squared is 196. Okay, so we know that this is going to give us square root of 221. Okay, so that is PQ for us, distance along PQ. Once we have this, let's put it down. Or we can decide to square both sides, right? Let's get that down. So we do that, we're going to have PQ all squared is equal to 2 to 1. Okay, so let's note this. Now let's find distance along QR. So distance along QR is equal to square root of the same formula, right? So x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so QR means that we are going to combine Q and R, right? So let's add the R. So R, which is 11 and 5, right? So here, our x1 is going to be this, our y1 is going to be this, our x2 and y2, right? So we do that substitution here. 11 minus x1, which is 8, all squared plus y2, which is 5, minus y1, which is 17. So right here. So distance for QR is going to be square root of 11 minus 8, which is basically 3 squared, plus this 5 minus 17 is 12, right? So we're going to have 12, negative 12 squared, right? So we're going to have square root of 9 plus 144, right? So we have this to be square root of 153. Okay, so let's try to do this, okay? Okay, so QR, right? So we have distance QR to be square root of 153. Okay, so now we take square on both sides to have 153, right? So we note this down here. Our last part, which is the PR. Okay, so let's go off with this. Let's go off with this, okay? So we're going to have PR. Okay, so PR means that our x1 is going to be 3, y1 going to be 3, and x2 going to be 11, and y2 going to be 5. So PR will be equal to square root of x2, which is 11, minus 3 squared plus 5 minus 3 squared, right? So we're going to have square root of 11 minus 3, which is basically 8. 11 minus 3, which is basically 9 squared plus 8 squared plus, so when you are doing these differences, you have to check it very well. Okay, so 11 minus 3, which is 8, all squared, plus 5 minus 3, which is 2. So we have 2 squared. Okay, so this is going to give us 8 squared, 64, plus 2 squared, which is 4. So we have this to be 68. Okay, so we have PR to be square root of 68. Now let's try to do away with the square root by squaring both sides. So we square here, we square here. So we have PR to be equal to 68, right? So PR is now at 68. So now we are going to follow the Pythagorean theorem, right? So you know that PQ all squared should be equal to QR all squared plus PR all squared. So what are you going to do? You're going to sum these two and check if it's going to be equal to the 221. So here we're going to have PQ all squared is equal to QR all squared plus PR all squared, right? We know that QR is 153 plus our PR is 68, right? So that should give us 221, okay? And this as well give us 221, right? So this indeed shows that the vertices P, Q, and R are the vertices of a right-angled triangle. So here we have 68 QR, we had 153, and we have 68, and we had. All right, so this is indeed, this has indeed proven that these vertices are the vertices of a right-angled triangle. Ladies and gentlemen, that is the end of the problem 1. Let's continue with problem 2. Okay, so this is problem 2. All right, so we are to find the coordinate of A and B, given that the straight line y equals x cuts the circle x squared plus y squared minus 6x minus 2y minus 24 equals 0 at A and B. And we are to also determine the equation of the circle which has AB as the diameter. Okay, so first of all, we are given a straight line, okay, and we are given equation of a circle. We are to find the coordinate of these two points, A and B. So what we have to do first is that since this is a straight line and this is a quadrat, this is an equation of a circle, we first of all substitute y equals x into this equation and find either of the equation to make sure that we have either the x coordinate or the y coordinate. Once we are done with that, then we come back to this equation of a line and find the other coordinate. Okay, so from here, we're going to use y equals x, or we put y equals x into the equation of the circle, okay? So into x squared plus y squared minus 6x minus 2y minus 24 equals 0, right? So we're going to substitute y equals x in place of wherever we see y, right? So here, we're going to say that x squared plus, wherever we see y, we substitute x, right? So we're going to have x squared minus 6x minus 2 into what? X minus 24 equals 0, right? So here, x squared plus x squared is going to give us 2x squared, okay? And minus 6x minus 2x becomes minus 8x minus 24 equals 0, right? So with this, we can say that we can use the quadratic formula, right? This is factorable. This is factorable. So we can factorize this. When you factorize this, we're going to have x minus 6 and x plus 2 equals 0, right? So this means that our x1 is equal to 6 and our x2 is equal to minus 2, right? So these are the coordinates for the x. So we have to find the coordinate of y as well. So in that, we are going to use the straight line. So using y equals x, then we can say that if x equals 6, then y equals what? 6 as well. So that becomes the first coordinate, and that can be the a. Okay, so we have 6, 6. And if x equals -2, then we can say that our y is also -2, right? So here we say that the coordinate for b is -2, -2. Okay, so we've satisfied the a part of the question. So hence the coordinates of a and b are 6 and 6, and also -2, -2, right? So we have the a part of the question. Let's move to the second part of the question, where we are asked to determine the equation of the circle which has AB as the diameter. Okay, so we know what diameter is. You know that when you draw a circle and you join two radii, right, it becomes a diameter, right? So we're going to do that here. So let's try to erase the question. Okay, so we take off the question from here. So we know that when you have a circle, okay, when you have a circle, this is a radius, okay? Once you extend from the circumference to the center of the circle to meet this as well, it becomes a diameter, right? So this is radius, and the whole of it becomes a diameter. So they said AB, right? So this is A and this is B. Okay, and we have the coordinate of A to be 6 and 6, and that of B to be -2, -2. All right, so we need the equation of the circle, right? That is what we are interested in. So what we have to do is to first use this coordinate A and B to find the midpoint of this what? Circle, right? So we have to find the midpoint. So we have to find the midpoint. So we have to find the midpoint. Find the midpoint in here with this coordinate. Okay, so the midpoint of AB will be equal to x2 plus x1 over 2 and y2 plus y1 over 2, right? So here we're going to have x2, which is -2, and x1 is +6. So it's going to be 6 minus 2 over 2, right? And we're going to have same thing here, 6 minus 2 over 2, right? So we're going to have the midpoint of line AB, right, to be 4 over 2 and 4 over 2, right? So this is basically equal to 2 and 2. So that is the midpoint of line AB, right? So now once we have the midpoint of line AB, then we are going to use the midpoint, and we are going to use the midpoint, and then we have to find the radius as well, because we are going to use the general form of the equation of a circle, right? So first of all, let's find the radius of this circle, right? So finding the radius of this circle, it means that we are going to find the distance along AB, right? So distance along AB will be equal to square root of AB, right? So you know x, our normal formula is going to be x2 minus x1, so it will be minus 2 minus 6 all squared plus minus 2 minus 6 all squared, right? So we're going to have minus 8 squared. That's going to be minus 8, 64, right? So 64 plus 64, and that is 128, right? So 128. So that is distance of A and B. So if you want to get the midpoint of this, then means you have to take half of this distance, right? So we are going to take half of the distance of A and B to get the radius of AB. Okay, so this, when you simplify it, you're going to have 8 square root of 2, right? So having this, the radius r will be equal to half of distance of AB, right? So we're going to have 8 square root of 2 over 2, right? So we're going to have 4 square root of 2. So that becomes what? The radius. So we're going to use this radius and the midpoint together with the general form of the equation of a circle. So here we know that x minus h, or well, you can use h all squared plus y minus k all squared equals r squared. That is the general form of the equation of a circle, right? So this h and k are the midpoints, right? That is the coordinate of the midpoint. So we're going to use 2, 2 for h and k, and the radius is right here. So we proceed from here. We know that our midpoint, which is the h and k, is going to be 2 and 2, right? So we have x minus 2 all squared plus y minus 2 all squared to be equal to square root of 4 times square root of 2. We're going to put it here. So we're going to have 4 square root of 2 all squared, right? So this is going to be x minus 2 all squared plus y minus 2 all squared equals, this squared is going to be 16 into 2, right? So we have x squared minus 2 times 2 times x is going to be 4x plus 4 plus y squared minus 4y plus 4 equals 32, right? So we're going to simplify this by bringing this to this side, right? So we're going to have x squared plus y squared minus 4x minus 4y. This and this becomes 8, right? So plus 8 minus 32, right? So in a nutshell, we're going to say that x squared plus y squared minus 4x minus 4y minus 32 plus 8 becomes minus 24, right? So we're going to have minus 24 in here. That is the process. You know, if whenever you are giving, you are not giving the coordinate, right? You are giving the problem that goes that a straight line and equation of a circle, and you have to find the coordinate. First of all, use the straight line, substitute into the equation of a circle, find either of the coordinates, then use the straight line to find the other coordinates. Once you have the other coordinates, Then you draw the equation of S. You draw the illustration of the circle, right? You know that when you join two radius or a radius, two radius is radii, right? So when you join that, you have your A and the B. So use the A and the B to find the distance along what? AB. Now, if you have the distance along AB, then taking half of it becomes what? The radius. Use that radius and the midpoint that you had to find the equation of a circle using the general form of equation of a circle. And that is the process. Thank you very much. I really appreciate your time. Please don't forget to keep learning as